So this again is from your 2.06 notes. I asked you to try 2 and 3, so the rest of that front page as your warm up. Table 4, which if any of these are equivalent to one another, and be able to explain why. Okay, the first 3 are all equivalent to each other. How did you come to that conclusion? Okay, so solving, when I say like solve an equation, what am I asking you to do, class? Find out what A has to equal to make it true. So table 4 is saying that for the first 3, if A is 3, that makes each of those true, and that's why each of these are equivalent. So first, let's see that they did the solving right, because that is a way to tell if something's equivalent. If they can be solved and they have the same answer, they are considered equivalent equations. But in this first one, when I'm isolating A, what do I have to get rid of first? And how do I get rid of it? And whatever you do on one side of the equal sign. So that will cancel it out here. We're getting a little closer to isolating A. What's 15 minus 6? And take a look. This, before I'm even done solving, matches this exactly. So if I were to continue, what's opposite of multiplying by 3? I should get the same exact thing over here, right? Because they are the same exact, nothing is different at this step. So for the first 2, definitely. Let's check this last one. If A equals 3, then it is also considered equivalent. You can probably guess and check this one. What plus 2 equals 5? But if that's not clear to you, isolate it. Undo what's being done. What's opposite of adding 2? Whatever you do on one side of the equal sign. And yes, it does. So that can be one way to tell that they are equivalent. Does anyone think that this one is equivalent to the rest? Okay. Table 5. The table 5. If I were to isolate and solve for this one using like the same way that they knew that these were equivalent, how can I isolate this A? What's something I can do? How can I make that 1/3 go away? Can you tell me what that 1/3 is doing to the A, table 5? What math is implied when it's a number up against the variable? Okay, what is opposite of multiply? So one way to say it is you could divide 1/3 on each side. Probably use a calculator if you're going that route, but it does work. What's the other way you could have canceled out the 1/3, class? Like instead of saying dividing by 1/3, you could also say this and it's also true. You cancel out a fraction. Multiply by the reciprocal. What is the reciprocal of 1/3? And whatever you do to one side. This one might be easier to do without a calculator, but you can do this. Like that would isolate the A. 1 divided by 1/3 is 3. But if you did the multiplying by the reciprocal, this might be easier to do without a calculator. Okay, but yeah. So this one is also equivalent. In this one, they're all equivalent to each other, although they do look different. If I can solve them all, then that proves they are equivalent. Okay, so now that's another way you can prove they're equivalent. sometimes you can't necessarily solve for A, like sometimes there's more than one variable. So if you look ahead to number 3. So this one. If you looked ahead to number 3, or actually this one only has one variable as well, so that one's not too hard. But let's look back at the one we did yesterday. So higher up on your note sheet. When you get to situations like this one where there's 2 variables, you can't really say that n equals this and they all have that in common, so they're all equal when it's more than one variable. Side note, when there's more than one variable in an equation, it's called a literal equation. And all you can really do to solve them is rearrange them. So yesterday when we went over these 3, we were trying to find all the different equations you could make to represent the middle child being 5 years older than the youngest child, right? There's lots you can do and probably even more that you could do than just what I wrote. Right, like you could write 5 plus y equals n. You could put n equals 5 plus y. Like there's probably other variations you could do, but does order matter in subtraction? It does. So like there's also things you can't do. To show you all the ways that we could have different equations for this, I took one that we knew was right, so like this one, and I just isolated different parts. So like in this one, m is alone. In this other one, I made the y be alone, and now it's a different equation representing the same thing. So these are still equivalent. And the way you do that is just like when you're solving, except for that you're not going to get y is this number, you're going to get y is this expression. Okay, you with me so far? Giving you gold here. So over here, you have to think, what do I need to do to isolate the y? How do I get rid of this 5? And that's what we did. And we can't really simplify this, so we just rewrite it. That's what we mean by rearranging the equation. They're still equivalent. Same thing over here. This one we isolated the 5 instead. And I looked at this one, so this one's probably easier to isolate to 5. I don't have to worry about the negative that's over here. But I looked at it and I said, how do I get rid of this y? And whatever you do to one side. And you can't really simplify it because they're not like terms, but you just rewrite it and now here's another equivalent equation. Okay. I know like when I was in 9th grade, that was hard for me to understand too. Like when it's all numbers, it makes sense, or one variable, it makes sense. And then when it's all variables, all of a sudden, it seems hard, but it's really not. It's the same exact steps from when you would solve normally. Undo what's being done in order to isolate. Okay, so that's how you can see if they're equivalent. If you can manipulate one to get the other, then they're equivalent. Or if it's like this and you can just solve them, you can do that too. So here is the other one I asked you to do. If you didn't do it yet, well, hopefully you can use what we just talked about and come up with an answer. So table 6, for your number 3, we're given this 5y equals 6. Which, if any of these bullet points are equivalent to 5y equals 6? Just tell me one. What do you know you say? Okay. So they're saying 15y equals 18 is equivalent to 5y equals 6. Table 6, why did you take that? Okay. Okay, so meaning like the variable equals the same thing, so they are equivalent, and they are. What would be opposite of multiplying by 5? So do that on both sides and simplify. 6 divided by 5 is 1.2. Over here, opposite of multiplying by 15 is, and put that in your calculator. You do also get 1.2. So good. Me, because I've done this for a while, my mind kind of went a different route versus just solving it. I looked at like, what could I have done to the first equation to get the second? Because if you can manipulate one equation to get the other, then they are equivalent. So that maybe you want to write somewhere in the margin. If you can manipulate one equation to get the other, because not all of them will necessarily be solvable like these ones, then they are equivalent. So when I was comparing these two, I thought, okay, what's one way I could go from 6 to get 18? What's something I can do? Multiply by 3. If they do the same thing on the other side, they're still keeping it equal. Right? Whatever you do on one side, you have to do to the other. Normally it's to isolate the variable, but sometimes we want to make the problem easier to solve. I don't know, like you'll see later in the unit why we might do that. But you're allowed to do whatever you want to both sides, and it's still equal. So since I did that, I can see that they are equal because I did the same thing on both sides. All right, good. Table 7. Is there any others that are equivalent to 5y equals 6? 5y plus 4 is 10. Okay, and how do you know? 6 plus 4 is 10. All right, so taking our original, and maybe I'm explaining it differently than you thought, feel free to interject. But what's the difference, say, well, I'll use what they said. 6 plus 4 is 10. And whatever you do on one side, that's to the other side. The left side is 5y plus 4. So they did do it on both sides. You can't really combine it and make it 9y or anything like that. They're not like terms. You just rewrite it next to it, and yeah, that does check out. Good. Table 8, are there any others that are equivalent to 5y equals 6? I agree, there's not. Just those two from that list. Because over here, think about it, what could I do to the 6 to get 12? And did I multiply by 2 on the left side? So definitely not equal. Over here, what could I do to the left side to make it 5y minus 1? Subtract 1. Did I subtract 1 on the right side? So then not equal. It's only equal if you do the same thing on the other side. Good? Or you could solve and you could see that they don't give you the same part. Okay, great. I think that's all I wanted to do on the 2.06. We're going to move on to 2.07 now, which is still something about equivalent equations, explaining steps for rewriting them. Kind of like adding 4 on both sides would be a step. Multiplying 3 on both sides would be a step. So let's move on to the paper you picked up today. We're gonna do a math talk, Kristen. We're gonna do a math talk, which if you don't remember, I'll refresh you on the rules. I put up a problem one at a time, and you try to do it without a calculator and without scratch work. Of course, if you want to show work, that's the only way you know how, fine. But these all technically could be done in your head. If you remember what it means for something to be a solution to an equation. So if I'm asking you, is 0 a solution to each equation? What am I asking you to do? Solve. You could try solving it. Does this one look that easy to solve? Yeah. Okay, matter of opinion. But like, what do you mean like solve? What am I having to figure out? The value of the variable that makes it true. So I'm asking you, is 0 a solution? Does plugging in 0 make it true? Get it? Okay. So when you think you know, yes or no, is 0 a solution to this first one, put your thumb up. Once I see enough thumbs, then I know we're ready to talk about. So is 0 a solution to this first equation? Okay, Amy, what'd you get? And why did you say no? How did you come to that conclusion so fast? Okay. Let me think. Macy, what'd you get? And why did you say no? Did you say because 0 plus 2 isn't 10? Okay, almost there. So you were supposed to plug in 0 into here, right? 0 plus 2 is what class? 0, and then you multiply it by 4. Which what's 4 times 2? Which is still not 10. So that's formally 1. Okay. But yes, this one is not a solution because it doesn't make it true. Now try this one. Try it without scratch work or calculator. If you can't, then I guess scratch work. But put your thumb up when you think you know whether 0 is a solution to this one on the screen. 12 minus 8x equals 3 times the sum of x and 4. In your head. Okay, Cadence, what'd you get? And why do you say yes? What do you do? So I just wrote down everything you said. You said 12 minus 0 is 0. Okay. But Yes, so since she said yes, this is what she did, it's kind of, it spoke a little bit there, but that's fine. She did get something that is true, so that is why she said yes, 0 is a solution to this. Make sense? Any questions? Plugging it in and seeing if it makes something that's true, I think would be easier than trying to solve this in your head, in my opinion, trying to isolate the variable in your head. Okay, so then next one. 5x equals 1/2 x, put your thumb up when you think you know, don't collaborate with other people right now. It's time to think about it. Put your thumb up when you think you know whether or not 0 is a solution to that equation. Okay, Jaden, what'd you get?
0 equals 0, so yes.
Okay, so 0 equals 0, so yes, 0 is a solution to this one. Class, what operation is implied when we have a number pushed up against a variable? Multiplication, so you have to remember, I'm multiplying now these numbers by 0, because that's what we're testing to see if it's equal to true. Anything times 0, fraction or otherwise, is 0. So this is a true statement. 0 does equal 0, so 0 is a solution for that. Last one for the warm up. Again, just think about it yourself. This is a independent activity. 6/x plus 1 equals 8. Put your thumb up whether you think it's 0 could be a solution. Ella, what'd you get? And why no? Okay, so the answer is that 0 is not a solution, but it's not because of what she said. 6 divided by 0 is what, class? Not 0. Not 6 either.
Is it 1?
Not 1 even.
Or is it, no.
Undefined.
Yeah.
It's impossible to divide by 0. Right? Think about it. If you're dividing something, splitting something up, can you split it up between 0 people? Exactly. So, if you ever get confused, like, let's see. Sorry, I'm just trying to get to Desmos and it looks like my thing went away, my shortcut. If you ever get confused, just try it out in your calculator. 0 divided by any number is 0, but the reverse is not true. You cannot divide by 0. So that is why it's not a solution, because it's impossible to divide by 0. Okay. It might say undefined or just give you an error message if you're using a traditional calculator. But that makes 0 not a solution for that one. Good. Any questions? All right, nice little activity. Normally, I would never ask you to solve something entirely in your head, but that does kind of help build some fluency. So moving forward, As long as you get the right answer at the end of the day, you could solve it however you want. But today for lesson 7, the goal is to think about why some steps for rewriting equations are valid, but others are not. And why some algebraic moves create equivalent equations, but some do not. And know how equivalent equations are related to the steps of solving and what it means to have no solutions and recognize that as an equation that has no solution. So we are directly teaching you some questions that are on your test, finding errors, and seeing if they are truly errors or if there's no solution. I'm recording right now, so that's always in the slides, even if I don't show the slides every day. You have an assignment for every lesson, usually not very long, but it can add up if you're slacking. But when is the last time you can turn in your practice for full points? By the end of that unit. So our end of this unit is September 25th is when we're testing. So the deadline for your late work from this unit would be the day before. So really, like, it seems like a ways away. If you look at the calendar on the whiteboard over there, it's just lessons every day, a quiz here and there. Quizzes, as you know, are kind of a drop in the bucket compared to our unit tests, but they are helpful in seeing where you're at so far and what you need to study and things like that. Right now, a lot of my students are sitting at good grades because the unit 1 test is like the highest class average it's ever been. So that's great. We still have opportunities, like if you're not happy with your grade, if you want to just make it better. We have opportunities, including my office hours on Fridays, you could come by. Or Saturday Academy, which is not every Saturday, but the first one is this Saturday. And I sent a message out through Parent Square, so hopefully you'll see it, probably already saw it, or you'll see it later today based on your settings. But basically Saturday Academy is where you come in on a Saturday from 8 to 10 and get some extra help, maybe retake some tests, use it as a study hall, whatever you want. And it's a completely free thing that the school offers. Normally, if you were to hire a tutor, at a minimum, it would cost you $50 an hour. And that's like a cheap tutor. I've had people pay me for my time up to like $100 an hour to teach them algebra 1 and 2. I don't do that with my own students, but like, I'm just letting you know, one-on-one tutoring can be very expensive. So whenever like your teachers have office hours or like these Saturday academies, there are teachers at Saturday academies. There are teachers from this school and ideally from all subjects. You don't need to just get help from your teacher. Any free help is always appreciated, right? So that's this Saturday in case you're interested. You don't need to like sign up in advance, you can just show up. But know that if you are failing right now, I will be personally inviting you. And I will let you and your parents know. If you're not actively trying to get your F higher, then odds are you will have to end up retaking the class. And right now it's really easy to get your F higher. You can just do some test corrections, but that does require you somewhat knowing what you're doing and being able to ask questions. So just keep that in mind. I have a couple stride things I need to enter, but if you're still failing after I put that in, then you are being invited. And if you don't come, like, don't say I didn't give you all the tools necessary for you to pass. Okay. Moving on back to this lesson. We're gonna skip this first activity that's on here. And we're gonna go straight to this one. So it's on the back of your 2.07 paper. So read along, this is great practice for your test. It says Noah is having trouble solving 2 equations. In each case, he took steps that he thought were acceptable, but ended up with statements that are clearly not true. Right, so let's see. 6 equals 1, clearly not true. 2 equals 3, clearly not true. So that's the problem that he's running into. You need to analyze Noah's work on each equation and the moves he made. Were they acceptable moves, and why do you think he ended up with a false equation? Discuss your observations with your group and be prepared to share conclusions. If you get stuck, try solving the equation yourself. See if you can figure out what they did and if that's an acceptable thing or not. So in summary, there might be an error, there might not be. If there's not an error and they're getting that, what does that mean? If there is an error, what should the solution actually be? I'm going to give you 3 minutes to try that. Read it yourself first. And then collaborate with your group. So did you find a mistake in number 1 at all?
I think it didn't have played at both sides.
Okay. So I appreciate you guys collaborating, but let's move on. Let's see if what our classmate said is true. And you said they should have added 3 to both sides. Like what step?
Yeah, that's what it's saying.
Okay, so let's evaluate that. Earlier someone said that the mistake was in the first line. Well, the first line is my original equation. Usually there's no mistake in your given equation. Usually that's just how they give it to you. So see like what the difference is from the first to the second. So class, visually, what's different from the first line to the second line? Okay, they switched a couple of the terms. They put the negative 3x in front of a positive 1, but otherwise there's no change. Is that allowed? You can do that according to the commutative property. That's the one that it works for addition or multiplication. But that one says that order basically doesn't matter in addition. And you might be thinking, well, order does matter in subtraction. Think of it this way. 1 minus 3, isn't that the same as doing negative 3 plus 1?
Yeah.
What do you get both times? Now, that's not necessarily what we would do here, but I'm just saying, like, they kept the 3x negative, they kept the 1s positive. All they did was change the order, so that is not wrong. If you thought that was wrong, it's actually fine, because they didn't change the sign. So, our friend is saying that there's a mistake from this line to this line. And that the mistake was that they didn't add 3x to both sides. What did they do? They did 4x minus 3x. What is 4x minus 3x? Okay, all this side conversation. If you're not answering me, then you shouldn't be talking. So I repeat, 4x minus 3x is what? 1x, positive 1x, or just x, which is what's showing here. So that's not incorrect. Yeah, I know it's what you said, but the problem is other people were talking. Okay, so I just need like the side conversations, the little comments. I don't care if you just said it. I need other people to talk about it. Understand?
Yeah.
Okay. So 4x minus 3x is what? And what's that called when we do that? Something else. I mean, there's words right here. So you are supposed to combine like terms. If they have the same variable to the same exponent, but I mean, you won't really see other exponents other than to the first power in this unit. But if they are the same variable, then you can combine the numbers in front of them. Combine means like adding a negative is the same as subtracting. So 4 minus 3 is 1, that is 1x, that isn't what is wrong. Maybe you were thinking like, we do have to move the variable to one side. You could have done it in this step, but it's probably wiser to combine like terms first and then move it. When you are moving a variable to one side, does it matter which one you move? Doesn't matter. You can move the left x to the right or the right x to the left. They're typically, I say pick the one that's smaller, and they're both the same. So just move one. How do you cancel it out? And whatever you do on one side is the equal sign. And that's acceptable, right? Aren't we allowed to do that? Isn't that what we're supposed to do to move a variable to one side? It just so happens that when I do that, it cancels on both sides, because what's x minus x? So then I end up with something like this. So it's not that the work is wrong. We just evaluated it, all the work is right in this one. When you get something that doesn't make sense and no mistake was made, what's your answer gonna be? Maybe you reread your learning targets that are on the front of your paper. When you get something that doesn't make sense and you're sure that a mistake was not made, what does that mean about this? Our learning targets, do you know where our learning targets are? Amy? Nope, undefined is when we divide by 0. Okay, there's no dividing by 0 in it. It has no solution is what we are looking for. So this is what it looks like when it has no solution. First, double check that you did all the work right. But if you still get something that is not true, 6 does not equal 1, that's a no solution. There is no value of x that would make it true. All right, questions on that? But now, you know, I tell students it is possible to have no solution, and then they want to say no solution all the time. You have to make sure that you're doing the work correctly, okay? So table 1, for the second problem I asked you to check, was there a mistake? And if so, like on what line? Guys, I can't make you like learn this stuff. I could yell at you to pay attention. I could, I don't know, deliver great lessons, make them all available to you all the time, but I can't make you understand it. You guys have to actually like try. You have to look at it, think about it. If you don't know right now, that's fine, but if you're not even like taking the time to look and pay attention, like, how are you going to be successful? It only gets harder from here. I'm not lying to you. Chris? So you think there's no mistake? Anyone disagree with that? Emberlyn, where's the mistake? Like from this line to this line? So let's see, in order to see if there is a mistake, hopefully you know how to solve yourself. Did they distribute correctly? Yes, usually that can be where a mistake is made. You have to take that outside number, multiply it by both of the inside numbers. And 2 times 5 is 10, 2 times x is 2x. That's not where the mistake was made. So now looking at this next one, C, what's the difference between this one and that one? What changed? And how did they make the 10 go away? They subtracted it. And whatever you do on one side. So that is why the 10 is no longer here, because it canceled out. And that's why the 9 became a -1. So what's 9 minus 10? So good try, but that is an acceptable move. Class, do we see a mistake from here to here? What would you recommend they do? Okay. From this step, I would recommend move the variable first. What they did was add 1 on each side first, but that's actually not like a mistake, I guess. It's just not the order I would recommend. So that's why the 1s disappeared, because when I add 1 to make this cancel, it also cancels this one. But really, I would recommend once you kind of get to this step, you move the variable to one side. Doesn't matter which one you move. I recommend the smaller one. It's really up to you. How would I move the 2x? Whatever you do to one side. What's 2x minus 2x? And since there's nothing else here, I'm actually gonna write the 0. Because normally we just write whatever else was there. There's nothing else there. So do write the 0. And then class, what's 3x minus 2x? 1x, or just x. And this is what they should have instead of this. While you could divide each side by x, like you're doing the same thing to both sides, it doesn't isolate the variable. When I isolate the variable, the x is alone, that's a condition, the answer is 0. Which is not the same as a no solution. X equals 0 is the solution. This incorrect. Okay, questions on that? Good? Made sense? A little bit better? Okay, well, that's all we're gonna do. I just put the high value activities. Be able to see, is there a mistake? You will be directly tested on that. Like if there's a mistake in the steps or in the words. And be able to say where the mistake was made and what the answer should be. I wouldn't just like wait around and wait for the bell to ring. I would take the time, put my notes away properly, because you have more than enough time to do that. And I would at least start one of the practices. They're usually not very long. But that's just.